Okay, so this is helping some people get caught up on modeling or reverse engineering this little piece, which is called the ultimate axle bushing we've purchased from Pitsco for our CO2 dragsters. And I've already sketched out what we did is we talked through and looked at and tried to understand what this teeny little thing is all about. So we see that it's cylindrical in shape, it's round, it's made to be inserted into a hole. It has a little flange, so a little piece that sticks out further. The intent of that is that when the narrower piece slides into a hole, that it won't be able to go all the way into the hole, so that flange will make contact with the outer face. So that's what's happening on the outside. On the inside of this piece, okay, we see a little hole on one side, and you might assume that it's kind of the same all the way through. In fact, with pulling out a caliper and taking some measurements, we find out that this hole is a larger hole than the hole on the opposite side. So it's intended to have an axle go through, in my drawing here, this blue piece, have an axle make contact for just a small length, just a small little distance, before it opens up and gets a little wider so that the axle doesn't have to make contact. So my pencil line here where the axle, right, that there's actually space here to reduce friction. Okay. Now with my caliper, I don't have the right tool to measure the length of that. And so we were just doing a quick mock-up to be able to show, an assembly. But if I stick a paper clip in there, I'm able to slide it along the edge and kind of feel that. And I can also visually see that it's really close to the outside. So it's even smaller than what is illustrated here. But I can feel that there is a lip, so that this is a smaller diameter there on the outside than on the inside. Okay? So we sketched that and then tried to illustrate what would it be to slice this in half and what would that profile be. So with this flange, we've got this slightly larger diameter where it's going to stick out, versus when we come down from that flange, it's going to be in just a little bit. That goes the full length. We have the wall thickness, and then it comes back most of the way, not all, but most of the way, right? I probably could have drawn that even further up. Most of the way before it turns in and creates a slightly smaller diameter hole, which is supposed to make contact with the axle and then return to the top. So that's it. It kind of looks like an asymmetrical T with a line over to the left that we can, if we produce a sketch, we can revolve it. So what I'm suggesting is we use our dollar caliper and we get ourselves about 6 different dimensions. So on the non-flange side, we have right here an outer diameter, but we will have to divide that by 2 to get the radius for this sketch. Okay. Right here, we will have an inner diameter that we'd be able to measure with our caliper. So I'm going to say ID, and we'll divide that by 2. We have the full distance, the full length of this part. And then we could also get the flange distance. No dividing by 2, just take those lengths. And then on the top end, we can have, again, 2 diameters. An outer diameter, we'll half it to get a radius for the sketch, and we'll get the inner diameter right here. So I'm saying ID and OD for outer diameter and inner diameter. Okay, those will be cut in half. So that's 6. The only dimension I'd be missing is this distance right here. Like I said, I don't have at the moment. We're not worrying about that detail. I'm going to let you guys decide if you wanted to investigate and make it your own in that regard. So if we pop over to Onshape, I already have a sketch ready. I'm sketching, and I'm going to start with a construction line. And this is going to represent my center line. Now, I know that my document is currently in inches. You want to be aware of what your document is in unit-wise and kind of think about your scale and stuff. This is a very small little part. So right now I'm making a segment that's 0.4, 0.5. That's inches, a half an inch. My piece is smaller than that, but I kind of understand the scale at which I'm working. and zoomed in, right? Because with CAD programs, you guys can be, a little line segment could be 100 feet long or a half an inch long, and they look the same on the drawing if you don't have a dimension. So with that said, I'm going to turn my line tool kind of back on, and let's see. I'm going to start with, how about the top? This might be like the flange. So I'm going to come back and add some dimensions here in a second, but I'm just going to illustrate this shape. So the flange comes down a little bit. It's going to cut back in just a little bit. It comes down the full length of my part, comes in towards an interior wall of that hole. And let's see. I need to not be left of that or aligned to that. So if I can find where that is, I need to make sure that I'm over to the right a little bit, and then I can come most of the way up. I don't want to be aligned to that. I don't think that's where it is. So I think it's actually closer to the end of the part. So I'm going to go further up and then make a little jog to the left. I get that alignment, and this right there, I'm going to accept that. I'm going to turn on the revolve tool, choose that profile, and choose the revolve axis. Now, I'm not done. I'm just illustrating here quickly. You can generally see the form. We're going to refine this by now going through and adding dimensions. Okay, so I'm going to go right back into that sketch, and we are going to be using our dial caliper. So make sure your dial caliper reads 0 when it's closed. And you could take a little more time. I'm going to be pretty quick for the sake of the video, but my needle's past the 0, so I'm at 0.3. So full length, what is that? 0.3. Like I said, I am going to be quick, so forgive me. But dimension from here to here is about 0.309. And then let me get the little flange distance right here. I'm going to measure this next. Make sure you hold your part square into your shape or into your caliper. It's not crooked or something to get an inaccurate dimension, but I'm at 0 inches and 0.10, 0.0, and then about 68. So 0.068. Now I need to get some diameters. How about I get the outer diameter first? I have to remember to cut these in half in my CAD here. So the outer diameter, this is on the non-flange end, okay, is, be careful not, this is just plastic, be careful not to compress or squeeze this. So it's a very subtle, gentle thing, but I'm about 1/4 of an inch. So let's go with that. 0.250. All right. Then I need an inner diameter on the same end. This is a very subtle thing, but I'm putting this in. I'm not wanting to compress this or to bite into the plastic, but I'm going to give just subtle pressure and give it a little rotation. I want to make sure I'm getting the diameter, not a smaller chord. And I'm about 0.150. And then I'm going to turn my attention to the flange side. Now, something just happened, and that is that lines moved in a way that they're not where I expect them to be. So I just turn off the dimension tool, and I'm going to manually adjust those lines to make sure they're on the right side of what I want. I don't want this to be, to the left of this line. I want them to be to the right. So I just manually kind of readjust that before I start dimensioning any further. All right, so the outer diameter, let's go ahead and create that. It might have moved on its own, but I find it kind of a good practice to keep things where I intend for them to be on the right side, and catch that before too long. So the outer diameter here on the flange end is about 0.312. And then the inner diameter, I'm expecting this to be smaller than what I had on the opposite side, but let's just see. Again, we don't want to bite into the plastic, so just subtle pressure here. I'm getting about 0.139. So 0.139. And that is still a little bit smaller than the other one. So I'm going to accept that. And something's wrong. Oh, I know. That was 0.139. I did not divide by 2. This 0.312 I did not divide by 2. Man, I didn't divide any of these by 2. This 0.150 is divided by 2. And my 0.25 I did not. I believe I said it, and then I'm just trying to be fast. I did not cut any of those diameters in half for radiuses, and that looks much better. There you go. So there is your ultimate axle bushing.